Good day, everyone. We are the Group 8. I, together with my group, Julito Limindog and Siti Elay Kagangis, will report about gases. So, the topic outline is we will discuss the properties of gases, we will discuss and solve problems involving gas laws, and lastly, differentiate and determine gas laws. What is gas? Matter exists in three distinct physical states: gas, liquid, and solid. Although relatively few substances exist in the gaseous state where typical conditions, gases are very important. For example, we live immersed in a gaseous solution. So gases is a gas uniformly fills any container and it is easily to compress. It also mixes completely with any other gases. Properties of gases is that it exerts pressure on its surrounding. They are easy to compress, they expand to fill their containers, and they occupy far more space than the liquid or solid from which they form. And now let's proceed gas laws, the different gas laws. What is gas laws? It is a simple mathematical relationships between the volume, pressure, and amount of gas. There are standard variables of gas laws, which is the pressure, the volume, the temperature, and the amount. The pressure is generally measured in kilopascals, while the volume is generally measured in liters. Temperature is generally measured in Kelvin, while the amount is generally measured in moles. There are six different gas laws, which is the Boyle's law, Charles' law, Gay-Lussac's law, Amonton law, combined gas law, and the last one is Ideal's law. Boyle's law. It was the relationship between pressure and volume. It was published by Robert Boyle in late 1600s, and he discovered that the gas volume and pressure are related mathematically. So he states that the volume of fixed mass of a gas varies inversely with the pressure of constant temperature. This box shows the molecules of a gas at a certain pressure, and the other one shows the same container with the same molecules. The mathematical representation of Boyle's law is volume equals constant 1 over pressure, or pressure volume equals constant. Ang K is monang constant, which means it will not change. If PB equals K, then the pressure times the volume will always equal the constant. Therefore, if you change the volume or pressure, it will still equal the same thing. So the volume times pressure will be the same before your change and after your change. Karon tuglaan ta mo unsaon niya pagkuha sa formula sa Boyle's law. For example, P2 ang gipangita. Ang formula niya is P1 V1 equals P2 V2. Pag P2 ang ipangita, divide ra ta og V2 para makancel ng V2 sa kilid, para P2 na lang mabilin, tapos mag-divide pud tag V2 sa kilid. So, mao na ning answer niya, P2 is equals P1 V1 over V2. And now, let me provide you an example. The first volume of a container of oxygen is 150 ml. Mo na tong volume 1. The first pressure of the container is 0.947 atm. Mo na ang atong pressure 1. If you change the pressure to 0.987 atm, which is the pressure 2 nato, what will the volume change to V2, the volume 2? So, ang gipangitaan ni nga problem is ang V2. So, kini na problem, ang gipangita niya is ang volume 2. Diba mo ang formula P1 V1 equals P2 V2. So, para mabili na din ang volume 2, mag-divide ta og P2 sa both sides, Then, i-cancel nato ng P2, so V2 na lang mabilin. Then, mo na naayahang formula na gamiton nato para makuha ang volume 2. Volume 2 is equals P1 times V1 divided by P2. Og mao na ni ang solution sa atong problem. V2 is equals to 0.978 atm which is ang atong P1 and 150 ml which is ang atong V1 over 0.987 atm which is ang atong P2. I-times na nimo ang P1 og ang V1 and divided by P2 and mag-cancel tas sa ATM para ml na lang mabilin og pag isolve na nimo tanan 144 ml ang answer niya.
Good day everyone, especially to you Mama Desa Sarabia. I am Julito Basikong Lumintog. Now I am going to discuss my topic, the Charles Law and the Gay-Lussac Law. So first is, I discuss the Charles Law first. So as you all know, Boyle's Law is talks about volume and pressure relationship, while Charles' law, it is mainly about volume and temperature relationship. So Charles' law states that the volume of a fixed mass of gas at a constant pressure varies directly with the Kelvin temperature. So it is the Charles' law states that the volume of a fixed mass of gas is constant, and the relationship of volume and temperature was discovered by the French scientist Jacques Charles in 1787. So he is the one who discovered the volume and temperature relationship. Also, Charles' experiment showed that all gases expand to the same extent when heated through the same temperatures intervals. And Charles found that the volume changes by 1 over 273 of the original volume at 0 degrees Celsius. So now I have here an illustration that would explain the volume and temperature relationship. So first, this box shows the molecules of a gas at a certain temperature. Let's imagine that the walls of the container are flexible like a balloon. So this box shows the molecules of a gas at a certain temperature. So as we can see here a box that the red dots or circles, it represent as molecules. So let's imagine that the walls of the container are flexible. So kaning walls diri let's just imagine na lang na kana is flexible like a balloon. So we all know that balloon their walls are very flexible. Next, or the next picture, the molecules of a gas move faster at a higher temperature, thus hitting the walls of the container more often and with more force or forces. So the molecules of the gas move faster at a higher temperature. So as a gas move faster, so typically it is cause a high temperature, and it is hitting the walls of the container often or always. Next is finally, or the last picture. Finally, the container must increase in size. As we can see, the kanang the increase in size sa container, the molecules will hit the walls left often. The lower frequency of impact offsets the higher force of the impact. So we always remember that the lower frequency of impact, it causes the higher force of the impact. So Charles' law, the average kinetic energy of gas molecule is more closely related to the Kelvin temperature. And Kelvin temperature scale is a scale that starts at the temperatures correspondingly to negative 7 or 200 or negative 273.15 degrees Celsius. This temperature is referred to as absolute zero and is given a value of 0 in the Kelvin scale. So it is a Charles law as a relationship of volume and temperature, or the kinetic energy and Kelvin temperature. So later I have or examples that would explain or would solve the problem, including the volume and temperature relationship. Now, this relationship is represented by the following mathematical expression. So K is equal to 273.15 plus C. So Charles' law can be expressed by the following mathematical expression. So Charles law can expressed by the following mathematical expression: V is equals to K T, or V over T is equals to K. The value of T is the Kelvin temperature. Again, the T is the Kelvin temperature, and K is the constant. The value of K depends only on the quantity of gas and the pressure. Again, the T is the Kelvin temperature and K is the constant temperature. So the form of Charles' law can be applied directly to the most volume and temperature involving gases is as follows. So this equation, or this equation can be applied to the most volume temperature or volume temperature problem. So we will use this equation. So V1, or initial volume over initial temperature, is equals to final volume and final temperature. Next, so as okay, V1 and T1, supposedly kaning 1 is gamay ni siya, so dili lang siya ma-encode, murag lisod sa encode as small 1. So V1 and T1 represent the initial conditions. V2 and or V sub 2 and T sub 2 represent the new sets of condition or kining final conditions. If 3 of the 4 to isolate the unknown variable and it solved. So I have here an example problem involving the volume and temperature relationship. So the first volume, or kaning V sub 1 or V1 of the element in E is 752 millimeter or ml. The first temperature, or kaning initial temperatures of the element, is 25 degrees Celsius plus 273, which is constant, so equals to 298 K. If you change the temperature, or if you change the temperatures T2 of the elements to 50 degrees Celsius, so 50 degrees Celsius plus 273, which is the constant, so the total is 323 K. What will the new volume be? So we will looking for the new sets condition of the volume. First, first is we need to arrange the equation to the V sub 2 is isolated. So for us to get the new sets of volume, so we put, or atong ibutang ang V sub 2 or the new sets of volume to the left for us to get the volume. So V2 is equals to V sub 1, or kaning initial volume, multiplied to the final temperature over the initial temperature. So now plug in the information that you have. So V sub 1, T sub 1, and T sub 2. So V sub 2 is equals to kaning V sub 1, as we all know, V sub 1 is 752 ml. T sub 2 is 323 Kelvin temperature over the initial temperature, which is the 298 Kelvin temperatures. The K in the bottom cancels out the K in the top. So i-cancel nato ning Kelvin at the bottom and Kelvin on the top for us para makuha nato ang new sets of volume. Now, plug the numbers into the calculator and you have your answer. So 752 multiplied to 200, or 323 I mean, divided by 298. So the total is, for the answer, is 815 ml or millimeter. So the 815 ml is represent as the new set of volume. So I am done discussing about Charles' law, the volume and temperature relationship. Now I'm going to discuss my next topic, which is all about Gay-Lussac's law, or the pressures temperature relationship. So in 1802, Joseph Gay-Lussac discovered that for every Kelvin of temperatures change, the pressures of a confined gas changes by 1 over 273 of the pressure at 0 degrees Celsius. And also, this law relates to how temperatures affect the pressures of gas when the volume is constant. So that is a discovery, or according to Gay-Lussac's law. So I have an illustration. So this box shows the molecule of a gas at a certain temperature. The volume have room to move around freely without bumping into the sides of the container too frequently. Next, this box shows the same container with the same molecules. If the temperatures has been increased, the gas pressure increases because the movement of the molecules become faster and have more kinetic energy. So, they hit the walls of the container with more force and more often. And Gay-Lussac's law can be expressed by the following mathematical expression. P is equals to Kt, or P over T is equal to K. The value of T is the Kelvin temperature, and K is a constant that depends on the quantity of gas and the volume. So this is a Gay-Lussac's law mathematical expression. So if K is always the same, then the P over T ratio will remain the same before and after you make a change. Therefore, you can set the initial P over T ratio to the change, or to change P over T ratio. So P sub 1 or P1 over T sub 1 or T1 is equals to P2 over T sub 2. So the P sub 1 here is the initial pressure, and T1 is the initial temperature, T2 is the new sets of pressure, and T2 is the new sets of temperature. So example problem, the first pressure, or the kaning P sub 1 or P1 of gas is 3.0 atmosphere or atm. The first temperature T1 of the gas is 25 degrees Celsius plus 273 constant is equals to 298 K. If you change the temperature T2 or T sub 2 of the gas to 53 degrees Celsius plus 273 Kelvin, the total is 329 Kelvin temperature. What will the new temperature be? So we are looking for the new sets of pressure, or kaning P sub 2. So find the second pressure, or kaning second pressure, or the P sub 2 or P2. First, rearrange the equation so the P2 is isolated. So para kuha na to ang P2. So P2 is equals to P1 multiplied to T1, or the new sets of temperature, over the first pressure temperature. So kaning P1 is here. So P2, or kaning ang atong P sub 1 is 3.00 atmosphere multiplied to T sub 2, which is 325 Kelvin temperature, over or divided by 298 Kelvin temperature. Now the K on the bottom cancels out the K on the top. Now plug the numbers into the calculator and you have your answer. So 3 multiplied to 325 Kelvin over 298. So the total is 3.27 atmosphere or atm. So this is the new set of pressure, which is the 3.228. 7. And it's in her my discussion. Thank you so much, and God bless.
The next gas law that we will be discussing is the Amonton's gas law. In a gas, its physical behavior is described by four variables, namely pressure, volume, temperature, and amount or mole. Now, Amonton's law is concerned in the relationship of pressure and absolute temperature. This is true when the volume is constant. Amonton's law was formulated by the famous scientist Guillaume Amonton in late 1600s. Amonton's law is best described in this example. During travel, the tires of your car will heat up because of friction. The temperature of the air inside your tires will increase, but volume of air does not increase because the volume is constant, hence result to the increase of pressure. The relationship of pressure and temperature follows the graph as shown. When we write it in mathematical terms, we have pressure is directly proportional to temperature. This relation can be also expressed as P over T is equal to constant. The pressure of temperature is equal to some constant. If we have a gas under two different conditions, we can write the formula as P1 over T1 is equal to P2 over T2. In the formula, we can see that under a certain condition of a gas, increasing the pressure would result to increasing the temperature, or decreasing the pressure would result to decreasing the temperature. I have here an example. The initial pressure is 1 atmosphere at 30 degrees Celsius. What is the pressure if we increase the temperature to 60 degrees Celsius? So first we have to identify the given. The P1 or initial pressure is equal to 1 atmosphere. Initial temperature is equal to 30 degrees Celsius. Final temperature is equal to 60 degrees Celsius. Now, the temperature must be in Kelvin. So we have to add 273.15. Therefore, the initial temperature is equal to 303.15 Kelvin. And final temperature 60 plus 273.15 is equal to 333.15 Kelvin. Since the final pressure is missing, we have to use the formula P2 is equal to P1 times T2 over T1. So 1 atmosphere times 333.15 Kelvin over 303.15 Kelvin, that would be 1.10 atmosphere. So the final pressure is 1.10 atmosphere. Now let us proceed to the combined gas law. But before that, let's just have first a quick review about the formulas of the previous gas laws that we learned. So Boyle's law is P1 V1 is equal to P2 V2, which simplifies to P2 is equal to P1 V1 over V2. In Charles' law, V1 over T1 is equal to V2 over T2. And then in Gay-Lussac's law, P1 over T1 is equal to P2 over T2. So what is combined gas law? From the word itself, combined, the combined gas law expresses the relationship between pressure, volume, and temperature of a fixed amount of gas. The combined gas law can be shown using the following mathematical expression. PV over T is equal to K. In the equation, K is constant and depends on the amount of gas. If K is always the same, then the PV over T ratio will remain the same before and after you make a change. Therefore, you can set the initial PV over T ratio to the change PV over T ratio. So P1 V1 over T1 is equal to P2 V2 over T2. Students often find this law the most difficult because of all the math involved. To simplify it, we will show you the equation with all 6 variables isolated. To find the initial pressure, the formula that we will be using is P1 is equal to P2 V2 T1 over T2 P1. And to find the initial volume, we'll be using the formula V1 is equal to P2 V2 T1 over T2 P1. And if we're looking for the initial temperature, the formula that we'll be using is T1 is equal to P2 V2 over T2 P1 V1. And for the final pressure, P2 is equal to P1 V1 T2 over T1 V2. For the final volume, V2 is equal to P1 V1 T2 over T1 P2. And for the final temperature, T2 is equal to P1 V1 over T1 P1 V2. I have here an example. A 35 ml bubble is released from a diver's air tank at a pressure of 4.5 atmosphere and a temperature at 288.15 Kelvin. What is the final volume when the pressure is at 1.5 atmosphere and the temperature is 293.15 Kelvin? So we have to identify first the given. The initial volume is equal to 35 ml and the initial pressure is equal to 4.5 atmosphere. Initial temperature is equal to 288.15 Kelvin and the final volume is missing. The final pressure is equal to 1.5 atmosphere and the final temperature is equal to 293.15 Kelvin. So we'll use the formula P1 V1 over T1 is equal to P2 V2 over T2. So we have to cross multiply it. Therefore, P1 V1 T2 over P2 T1 is equal to P2 V2 T1 over P2 T1. So, i-cancel nimo ang P2 pati ang T1. So, therefore, the formula that we will be using is V2 is equal to P1 V1 T2 over P2 T1. Solution. V2 is equal to 4.5 atmosphere times 35 ml times 293.15 Kelvin over 1.5 atmosphere times 288.15 Kelvin. So, 4.5 atmosphere times 35 ml times 293.15 Kelvin is equal to 46,171.125 ml. And 1.5 atmosphere times 288.15 Kelvin is equal to 432.225. So, V2 is equal to 46,171.125 ml over 432.225. So the final volume is equal to 106.82 ml. I have here another example pa dyan. So, the oxygen tank manufacturer used to produce 6.0 liter oxygen tanks at 2,100 psi and 27 degrees Celsius. Statistics suggests that the 4.0 liter oxygen tank at 1,600 psi more marketable. Compute for the final temperature. So just like sa ating gibuhat gaina, we have to identify first the given. So the initial volume is equal to 6.0 liter. The initial pressure is equal to 2,100 psi. The initial temperature is equal to 27 degrees Celsius plus 273.15 Kelvin is equal to 300.15 Kelvin. The final volume is equal to 4.0 liter. Final pressure is equal to 1,600 psi. And the final temperature is missing. Then the formula P1 V1 over T1 is equal to P2 V2 over T2. So we have to again cross multiply it. So the formula that we'll be using is T2 is equal to P2 V2 T1 over P1 V1. T2 is equal to 1,600 psi times 4.0 liter times 300.15 Kelvin over 2100 psi times 6.0 liter. So 1600 psi times 4.0 liter times 300.15 Kelvin is equal to 1,920,960 Kelvin, and over 2100 times 6.0 liter is equal to 12,600. So 1,120,960 Kelvin over 12,600 is equal to 152.46 Kelvin. So therefore, our final temperature is 150.
And now let's proceed the ideal gas law, the last gas law. Ideal gas law is an equation of a state of the gas where the gas is its equation at a given time. A particular state of gas is described by its pressure, temperature, and number of moles. It is an empirical equation, means based on experimental measurements of gas, a gas that this equation is said to behave ideally. These three laws describe the behavior of gases which experimental observations: the Boyle's law, Charles' law, Avogadro's law. Boyle's law, V equals Q over P at constant T and N. Charles' law, volume equals BT at constant P and N. And Avogadro's law, which is the V equals AN at constant P. This relationship shares how the volume of a gas depends on pressure, temperature, and the number of moles of the gas present, and can be combined as V is equals to R open parenthesis Tn slash P close parenthesis to PV equals nRT, where R is the combined proportionality constant that is called universal gas constant. Ang ihang value is 0.0820 liters ATM constant mole. So example, a sample of hydrogen gas had a volume of 8.56 liter at a temperature of 0 degrees Celsius and a pressure of 1.5 atm. Calculate the moles of each two molecules present in the gas sample. So, ang atong pangitaon ani nga problem is ang H2 or ang N. Na naman tay number sa V, sa P, and sa T, which is the 0 degrees Celsius plus 273 na mao ang value sa Kelvin. Mo na ning solution niya kay N man ang atong gipangita. So, N is equals to 1.5 atm times 8.56 liter over 0.0806 k atm over constant mole times 273 Kelvin. Tapos pag ato na nang i-solve, ang answer niya is 0.57 mole. Sample number 2. Suppose we have a sample of ammonia gas with a volume of 7.0 ml at a pressure of 1.68 atm. The gas compressed to a volume of 2.7 ml at a constant temperature. Use the ideal gas law to calculate the final pressure. So, diri na problem ang gipangita is ang P2. Kay na naman tay P1 which is the 1.68, volume 1 which is the 7.0 ml, and the volume 2 which is the 2.7 ml. Solution. PV is equals nRT, where PV is the variables that change and the nRT is ang mga variables na nag-remains constant. Since N and T remain the same in the case, we write P1 V1 equals nRT and V2 V2 equals nRT. Atong gamiton sa P2 na formula is P2 equals V1 over V2 P1. So, pag ato na nang i-solve tanan, ang result niya is 4.4 ml. That's all. Thank you. Once again, good day everyone.